Imagine a world where machines can think, learn, and even make decisions just like us humans. Welcome to the realm of artificial intelligence. The idea of artificial intelligence, or AI, is not a new phenomenon. Its roots can be traced back to ancient times when people dreamed of creating autonomous machines. However, it was only in the mid-20th century that AI began to take shape as we know it today. The role of artificial intelligence in our lives has grown exponentially in recent years. From our smartphones to our home appliances, and even in sectors like healthcare, finance, and transportation, AI has become an integral part of our daily lives. It's fascinating to see how AI has evolved over time, from simple program machines to complex algorithms capable of learning and adapting. The journey of AI from a nascent concept to a transformative technology is truly remarkable. But how did it all begin? The seeds of artificial intelligence were sown with the fundamental idea of replicating human intelligence in machines. But what does this mean exactly? At its core, artificial intelligence, or AI, is about programming machines to mimic the cognitive functions that humans associate with the human mind, such as learning and problem-solving. Now let's turn back the clock to the mid-20th century. Early AI researchers were filled with optimism, envisioning a future where machines could fully replicate the human mind. They attempted to translate complex psychological processes into machine-readable formats. However, these early attempts were largely unsuccessful due to limitations in both technology and understanding of the human mind. Despite the initial setbacks, these pioneers laid the groundwork for future advancements in AI. They set the stage for creating machines capable of learning, reasoning, perceiving, and understanding language, much like us humans. This foundational stage set the scene for more advanced developments. And that brings us to machine learning. Machine learning is the next significant milestone in the AI timeline, opening up a world of possibilities. Imagine a world where machines not only perform tasks, but also learn from their experiences, improving over time. That's the magic of machine learning, a subset of artificial intelligence that provides systems the ability to learn from data and improve from experience without being explicitly programmed. Machine learning is central to AI because it equips systems with the ability to analyze, interpret, and make predictions based on large amounts of data. It's like teaching a child to recognize patterns. Once the child learns the pattern, they can apply that knowledge to new situations. Let's take a moment to appreciate some of the practical applications of machine learning that are transforming our world. From personalized recommendations on streaming platforms to self-driving cars, machine learning is everywhere. Ever wondered how your email filters out spam? That's machine learning at work. Or how about the way social media platforms suggest people you may know? Again, machine learning. Now, you might be wondering how machines learn. Well, that's where key algorithms come into play, such as regression, classification, and clustering. Regression helps in predicting continuous outcomes like the price of a house based on its features. Classification, on the other hand, is about predicting discrete outcomes. Think email spam filters. And then there's clustering, which is all about grouping similar things together. For instance, clustering can be used to segment a company's customers into different groups based on their buying behavior. But machine learning isn't just about algorithms, it's also about the data. Without data, machine learning would be like a car without fuel. It's the data that machines learn from. The more data, the better the learning. Machine learning gave AI the ability to learn from experience, but the journey didn't stop there. Enter neural networks. Inspired by the human brain, neural networks brought a new level of sophistication to AI. Neural networks, as the name suggests, are modeled after the neural connections found in our brains, a magnificent web of neurons firing and connecting, creating the very essence of our thoughts and consciousness. These networks revolutionized artificial intelligence, moving it beyond simple pattern recognition and towards a more profound understanding of data. The invention of artificial neural networks, a type of machine learning model, was a milestone in this journey. They were designed to mimic the way neurons in our brains interact, creating a system capable of learning and adapting. This adaptability is the crux of the neural network's strength, allowing it to tackle more complex problems. For instance, in the past, a computer trying to recognize a handwritten digit would need explicit instructions for every possible variation. But with neural networks, the system learns by example, identifying patterns and refining its understanding with each new piece of data. neural networks have found success in a wide range of real-world applications. They're behind the scene in your email spam filter, learning to distinguish between important messages and junk mail. They're the power under the hood of self-driving cars, enabling them to recognize traffic signs, pedestrians, and other vehicles. They're even used in medicine, helping doctors to diagnose diseases by analyzing medical images. But the story of neural networks doesn't end here. As impressive as these feats are, they represent a fraction of what our human brains can do. So the quest continued, pushing the boundaries of what artificial intelligence could achieve. The desire to harness even more of the brain's power led to a new frontier in AI: deep learning. Neural networks enabled AI to tackle complex problems, but the quest for more power led to the rise of deep learning. Deep learning takes the concept of neural networks to new heights, driving AI into an era of unprecedented capabilities. Imagine neural networks as the brain of artificial intelligence. Deep learning, then, is like a brain on overdrive. It's a subset of machine learning that uses multi-layered neural networks to analyze various factors at once. This multi-tiered approach allows deep learning models to process high-dimensional data in a way that's much more sophisticated than traditional machine learning methods. Let's delve into some popular architectures in deep learning. First up, we have convolutional neural networks, or CNNs. These are primarily used in image processing and have been the driving force behind the development of computer vision. They're designed to automatically and adaptively learn spatial hierarchies of features, which is a fancy way of saying they can recognize patterns in images that are far beyond human capabilities. Next, we have recurrent neural networks, or RNNs. These focus on time series data, like speech and text, where the sequence of information is vital. RNNs have this unique ability to remember previous inputs in the sequence, making them ideal for tasks that require understanding the context in a body of text or recognizing the words in a spoken sentence. Deep learning has played a pivotal role in enhancing AI's ability to process complex information, from enabling self-driving cars to navigate traffic, to voice assistants understanding and responding to our commands, to algorithms detecting diseases in medical images. Deep learning has been at the forefront. But let's not forget, deep learning is just a tool. It's the intricate dance between algorithms, big data, and computing power that brings AI to life. And while deep learning has given AI a significant boost, it's also highlighted the challenges we still face. It requires large amounts of data and processing power, and often its decision-making process is a black box, even to the engineers who built it. Deep learning has pushed the boundaries of what AI can accomplish, but the ultimate goal is general artificial intelligence. General artificial intelligence represents the pinnacle of AI, where machines can perform tasks in a way similar to humans. It's the fifth stage in the evolution of artificial intelligence, a stage that is still being explored and perfected. Imagine a machine that can understand, learn, and adapt to new situations just like you and me. It could solve problems, make decisions, even express emotions. That's the dream of general artificial intelligence, often referred to as AGI. But achieving this dream is no easy feat. Currently, AI excels in narrow tasks, ones that are specifically defined and limited. But general AI is all about versatility and adaptability, the ability to learn and apply knowledge across a wide range of tasks. And that, my friends, is a massive leap from where we stand today. There are significant challenges in our quest for AGI. For one, we don't fully understand human intelligence yet, let alone replicate it. And then there's the issue of computational power. The human brain is an extraordinarily efficient processor, and matching its capabilities demands immense resources. But perhaps the biggest challenge lies in teaching machines to understand context, to learn from experiences, and to apply that learning in novel situations. It's about developing a machine that doesn't just mimic human behavior, but truly comprehends it. And as we inch closer to this reality, we must also reflect on the ethical and social implications. What does it mean for employment, privacy, even our very identity as humans? These are questions we need to grapple with, as the line between human and machine intelligence becomes increasingly blurred. The quest for general AI continues, with all its promise and challenges. But one thing is clear: AI has transformed and will continue to transform our world. From self-driving cars to virtual assistants, it's already making a significant impact. And as we venture into the realm of AGI, that impact is only set to grow. And from its foundational concepts to the dream of general AI, the journey of artificial intelligence is a testament to human ingenuity. We've seen how it all started with the fundamental principles, the early attempts at replicating human intelligence in machines. Then came the era of machine learning, leveraging key algorithms like regression, classification, and clustering to give machines the ability to learn from data. The advent of neural networks followed, mimicking the human brain to solve more complex problems. The surge of deep learning took neural networks to new heights, enhancing the capacity of AI to process intricate information. Finally, we've glimpsed the quest for general AI, the ambition to equip machines with the ability to perform tasks just like a human. The impact of AI, both now and in the future, is immense. It's transforming our society in ways we could have never imagined. As we stand on the brink of a new era in AI, we invite you to share your thoughts and questions, because the story of AI is far from over.